Hello, this is Mr. Henry, and welcome to lesson 6.7. This lesson is entitled Solving and Graphing Linear Inequalities. So today what we're going to do is we're going to combine a couple of things we've done before. We're going to have these inequalities where we have the arrow that we shade in, and then the shading on one side or the other, that sort of deal. Except now, instead of just being on a number line, we're going to take that and expand it to a two-dimensional grid, like an XY coordinate plane. And we're going to have a line going through there. And then we're going to have to shade maybe to the left or the right or the top or the bottom. And we'll see how that works throughout the lesson. Okay. The get the goof that we have here is from the last lesson. So let's see how they did. They took this, and it should be x minus 5. The first one you're not supposed to switch anything. They switched this sign, so it should still be a greater than. And then when you'd add 5 and add 5, we would get 12. So it should be x is greater than 12. And on this side, you switch the sign and you switch the sign of the inequality. Then when you add 5 and add 5, that would give you a negative 2. So a bunch of just little mistakes there, but it's enough of a mistake that if you don't get that part, it could mess you up on the stuff we're doing today. So we have two vocab words here. The first one is linear inequality in two variables. And you could probably guess by the name, it's two variables in one linear, it says equation. It should be inequality. So that'd be like 3x plus 2y is greater than 18 or something like that. And for the solution of linear equation in two variables, it is the ordered pair that produces a true statement when x and y are submitted into the inequality. Basically, it's all the numbers you could plug in to the inequality, and that thing is true. So for example, here, in this one up here, if we plugged in like 10, or x equals 10, let me get my marker out. So if we plugged in x equals 10 and y equals 0, if I plugged in that, x equals 10, so that'd be 3 times 10 would be 30 plus 0. Is that bigger than 18? Yes. So the point 10 comma 0 would be a solution to this inequality. And we're going to see there's actually like an infinite number of solutions for these problems. Okay? So before we get into the actual graphing, let's start by determining whether an ordered pair is a solution. So I want to know, is that 0, 0 for letter A a solution to this inequality? Well, you plug the x value in for x, the y value in for y, and then do the math. So 0 minus, this is 0, 2, is 0 less than or equal to 6? The answer is yes. So that means this point is a solution to that inequality. It works. Letter B, do the same thing. We plug the x value in for x, the y value in for y. This is x and y. So we get a negative 0, which is just going to be 0, plus 2 times 4, which is 8, and we want that to be less than 8. Well, if we simplify, is 8 less than 8? The answer is no. 8 is not less than 8, so this point is not a solution. Okay, so x value in for x, y value in for y. Do the math and see if the thing it gives you is true. If it's true, it is a solution, like example A. If it's not true, it's not a solution. I would like you to please try letters C and D right now. Okay, hopefully you've done by now. If not, go ahead and pause the video and do it. So let's see. We plug in 0 for x and 0 for y. So that becomes 0 plus 2 times 0 is greater than 8. 0 plus 0 is greater than 8. 0 greater than 8? No. So this is not a solution. Letter D, x and y. So x is x is 3, so we get the negative 3, plus 2 times 5, we want that to be less than 8. So let's see, negative 3 plus 10 is less than 8, is 7 is less than 8. Yes, 7 is less than 8, so this is a solution. That point worked for that inequality. Okay, what we just did here is good to do to check your solutions as we're doing the next stuff, but this is really not the majority of the lesson. The majority of the lesson is the very next thing, graphing our linear inequality in two variables. So if you remember back in, what was it, chapter 4 or 5, when we did all that graphing, we had like slope-intercept form, we had point-slope form, we had standard form, and we learned how to graph from each of them. This is the same deal. You make that inequality look the way you want it to look, and then you can graph it. Me personally, I like slope-intercept form. Slope-intercept form looked like y equals mx plus b. This is an example of slope-intercept form. So I'm going to graph that the way I did before. I'm going to put a point at my intercept, negative 3. I'm going to move the way the slope tells you to move. So this problem has a slope of 4. As a fraction, that's 4 over 1. So I'm going to go up 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Now, don't work ahead. If you do, you might make some mistakes here. If you remember back when we had our inequalities, so let's just say, for example, we have, we're going to simplify, make a y is just greater than 4. No x, no other stuff. This is a separate problem. And when we graphed that, we had our number line. We put 4 in the middle, and 5 and 6, and then 3 and 2. Now, we needed a solid dot or a hollow dot. Remember that? And the way you tell was the inequality. Well, we have the same sort of deal. Here, instead of having a solid line, we could get a solid line or a hollow line. And hollow line is basically just a dotted line. So we could have a solid line or a dotted line. And the way we know is just the same way as before. A solid comes with the or equal to's. A dotted line, or a hollow line, is just a greater than or less than. So from these 3 points, I need a dotted line, a hollow line, because when we solved, or because the inequality has this greater than symbol. So we're going to make just a dotted line through these with arrowheads on the ends. Okay. The dotted line came because we had a greater than symbol. If it was greater than or equal to, we would use a solid line. So think of the lines kind of like the dots. You got a solid dot, hollow dot. Solid line, hollow line. This problem, we had the hollow line. Now, I mentioned that we were going to be shading. Here's a little trick I use to figure out which direction to shade. The way you tell which direction to shade, this symbol here is a greater than symbol. Greater than symbols, you shade above the line. So look at the line. If you put your pencil in the line and you go straight up, this is where you want to shade, up here. So all of this stuff above the line is the area that we want to shade. So what this means for us is every single point that we are shading in, every single point above this line is a solution. Now, even down here and out here and over here, up until that dotted line, all of this stuff is a solution. All these points are solutions. If I pick any of them and plug them into my inequality, we should see that it works out. Let's check. I'm going to take a point at random. Let's call this one. We're going to plug it in. So this is the point -1, 2. If I plug the -1 in for x, the 2 in for y, this should be true. Let's check. 4 times -1 is -4. -4 minus 3 is -7. Is 2 bigger than -7? Yes. Check. It worked. I could pick another point if I wanted. How about like this one way down here someplace? And that would be an x value of -1, y value of -1, -2, -3, -4. So -4 is greater than 4 times -1 minus 3. This, again, is going to give me a -7 on this side and -4 there. Is -4 bigger than -7? Yes. So this point checks out too. I could pick a point on the other side of the line, and it should not work. So if I picked, say, this point here, this is the point 1, 2, 3, 4, 5, comma 2. So if I plug in 4 times 5 minus 3, it should be greater than 2. Well, 4 times 5 is 20. 20 minus 3 is 17. Is 2 bigger than 17? No. That point did not work because this is not true. The last thing I want to point out here before we look at the second problem is if I picked a point on the dotted line, for example, maybe one of these points that we plugged in, or these points that we drew in here, they will not work either because it is a hollow line. And the hollow line says that the points on that line are not solutions, but everything just over the line is a solution. Okay, so let's see. Let's pick one of these points on the line and try it out. So I'm going to use green. I'm going to pick this point here, which is the point 1, 1. 1, 1. So 4, 1 minus 3, 1. 4 times 1 is 4, minus 3 is 1. Is 1 bigger than 1? No. So that point is not a solution. But as soon as I cross over this line and I go over here a little bit, that would be a solution. Okay? So hopefully you understand why we're doing this shading, why we have a solid line or a dotted line. Let's see a second example. Here we have this inequality. The first thing that I want to do is I like graphing using slope-intercept form. That's slope-intercept form. So I want to get the y by itself and everything else on the other side. So I'm going to start by subtracting x. Get rid of the adds and subtracts first. And in case you're curious, you really do not need to write plus 0. You could. It doesn't hurt, but you really don't need it. Divide by 2 on both sides. These cancel. Y is less than or equal to. This, as a fraction we've done before, will be a -1/2 x. And 0 divided by 2 is 0. So now, let's graph. We're going to start by putting a point at the y-intercept, which is 0. And then we move with this slope. So we're going to go down 1 over 2. Down 1 over 2. Down 1 over 2. Down 1 over 2. And we've got space. We can do 1 this way. Do the reverse. Up 1 over 2 the other way. Now, we have to decide if we need a solid line or a hollow line. The answer is it's definitely going to be a solid line because it has this or equal to underneath. So this is a solid line, and I'm going to cheat so I can make a straight line. There you go. And you need your arrowheads on it. So we need a solid line, And we need to figure out which direction we're going to shade. Do we shade above the line or below the line? Well, this symbol is a less than. Looks like an L. Less than. So if you put your pencil on the line or on one of these points and you go less than, which is down, that's the area you need to shade. So we're going to shade all of this stuff down here. That is the solution of this inequality. Every single point we shaded in is a possible solution. It is a point that works in this inequality. Okay? So we've done two together now. I'd like you to try one. This is letter C. So go ahead and pause the video. Go graph it, shade it, all that good stuff. And when you're ready, hit play, and we'll go through it together. Okay? There are a variety of ways you could have done this. So if you did this using slope-intercept form, that's how I'm doing it. If you graphed it another way, let's just make sure your graph looks like mine. So I'm going to start by subtracting x on both sides because I want to get the y variable by itself. And I divide by 4 on both sides to get the y by itself. Y is less than. This, as a fraction, does not simplify, so negative 1/4 x. This does simplify. 8 divided by 4, actually it's a negative 8 divided by 4 is a negative 2. So now we put our point at negative 2, it's our y-intercept, and we move with that slope. So we're going to go down 1 over 4. Down 1 over 1, 2, 3, 4. I'm out of space this way. We can do the reverse. Up 1 over 1, 2, 3, 4. Up 1 over 1, 2, 3, and we'll be out there someplace. That one's kind of faking it. So now we need a line. Do we need a hollow line or a dotted line? The answer is we need a dotted line because this is just a less than. So I'm cheating again. I like cheating. There is my dotted line going through those points. You should use maybe an extra sheet of paper or your folder or a textbook or a note card or cell phone or whatever you have, an extra pencil to make that straight line if you can. Now, do we shade above the line or below the line? Well, let's look at the inequality. The inequality is a less than, so we shade less than the line. Below the line, lower than the line. So we shade this area down here. And we're done. So that problem wasn't terribly bad either. So hopefully you've seen that this is not terribly different from what we've seen before. Yeah, this graphing thing here is, or the shading of it is, but for the most part it's kind of the same. The next examples we have are what happens if you have only one variable. Here I don't have like a y equals mx plus b thing. I don't have that x variable or a slope or an intercept. All I have is y is greater than or equal to negative 3. So what you do is you ask yourself, well, where is the y value negative 3? Well, the y value is negative 3 right here. Where else is the y value negative 3? Well, over here, or there, or there. Any place along this line, right here, the y value is negative 3. Think about it. This point right here has an x value of 1, 2, 3, 4. So this point has the value 4, comma, negative 3. So you went down 3. So the y value of negative 3 is anything along this line. And what we want to shade in, it says, is anything bigger than or equal to negative 3. So because we have that or equal to, we're going to use a solid line, and bigger than negative 3, hopefully you can guess which way that is. If you're going bigger than negative 3, you're shading above it. This. is bigger than negative 3, because there's like 0 and positive 1 and positive 4 and all that kind of good stuff. Okay? Letter B. It says x is less than negative 1. Well, where's negative 1? Or the x value of negative 1. X value of negative 1 is here, or here, or here, or here. Any place you go over 1 and then up or down, that line has an x value of negative 1. Okay? Do we need a hollow line or a solid line at negative 1? Well, we need a hollow line. And then which direction would we shade? Would we shade less than it? Because like negative 3 is less than negative 1. Or would we shade bigger? Positive 2 is bigger than negative 1. Well, let's look at the inequality. We want values less than negative 1. Well, they'd have to be this way. These values are less than negative 1. So, pretty self-explanatory when you sit and think about it. Probably seems mysterious at first, but then you go, oh, it makes sense. I would like you to do letter C, please. So you're going to graph where the y values are bigger than 5. Go ahead, pause the video, do that on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, y value is bigger than 5. Well, the y value is 5. 1, 2, 3, 4, 5. Anywhere up here across this line. Anywhere where you go up 5 from the x-axis. Then we need to have a hollow line because it's just greater than. So we put a hollow line or a dotted line. And then we need to shade which way, above it or below it. Well, since it is a greater than, we're going to shade greater than 5. 6 is bigger than 5, and 7, and all this stuff up here is bigger than 5. And that would be the solution. All right. The next thing I'd have you do is just a couple problems from the textbook. Here's page 407, numbers 6 and 7. Go ahead and graph these two inequalities on the space provided for you, and then we'll go on from there. Pause the video, do it now. Okay, hopefully you had time to do, so let's see how you did. So y is less than or equal to less than or equal to 3. So the y value of 3 is along this line. So you need a solid line because it is or equal to. See, or equal to. And then we want to shade less than that. And that's what we should get. Number 7, we need a line at x is less than negative 2. So x is negative 2 right here, and here, and here, and here, and here. We need a dotted line, or a hollow line, because it's just less than. And we need to shade less than negative 2. And less than negative 2 is this stuff over here. And would be done. Okay? Last two problems are just two application problems. It says here, a farmer can make $8 per bushel of peaches and $4 per bushel of cherries. Already in my head, I have some stuff going. I don't know if it's right or wrong, but I'm going to write down what I think. It's going to be $8 times the number of peaches plus $4 times the number of cherries. So 8 times the number of peaches plus 4 times the number of cherries. That gives us like the total amount they made. The farmer wants to make at least $350. So at least $350 is that much or more. If you have to be at least 3 feet to ride the roller coaster, you can't be less than that. You have to be that much or bigger. So he wants this stuff, the amount he makes, to be bigger than or equal to 350. Selling his fruit. Write and graph an inequality that represents how many bushels the farmer needs to sell of each type of fruit. So this is basically the inequality. Now this is our verbal model. So we just need to take this and turn it into a more of a math problem, but with letters and numbers instead of like of and stuff. So let's just, for the sake of this problem, we'll call peaches X and what was the other one? Cherries Y. So it's going to be 8x, 8 times the number of peaches, plus 4y, that's the number of cherries, and we want that to be bigger than or equal to 350. That is a bona fide inequality. So write the inequality, boom, we're done. Next thing we need to do is we need to graph that inequality. Okay, so to graph that inequality, the way we've done it before is we had to maybe, like the way I did it, is I put it inside slope-intercept form. So I'm going to get the y by itself. So I'm going to start by subtracting 8x. We get 4y minus 8x plus 350. I'm leaving some space over here for my labels and units and that kind of stuff when I graph. Divide by 4, divide by 4. These cancel. Y is greater than or equal to negative 2. That's negative 8 divided by 4 is negative 2. X plus 350 divided by 4. 87.5. Alright. So, now we have our inequality solved for y. Now we can graph this thing. So, bushels of, what did we say the x was? Peaches. P-E-A-C, I can't spell peaches apparently. P-E-A-C-H-E-S. And then this is bushels of cherries. You're thinking, why the heck is he writing it way over there? Well, I'm going to do this. I'm going to cheat it. There. Okay. Now, I know my y-intercept has to go up to about 87.5. Well, to go to 87.5, I've got to go, like, count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90. 87.5 would be, like, right there someplace. Okay? So, let's have a scale of 10. I think that will work good for us. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And then bushels of peaches would be the same scale. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Alright, so the y-intercept is 87.5, which is like right here. That's my y-intercept. Now the slope is negative 2. So from here, if I go down 1, down 2, over 1. Remember? Because this as a fraction is negative 2 over 1. Down 1, down 2, over 1. Down 1, down 2, over 1. Down 1, down 2, over 1. So you see we have a line here. We need a solid line through it. And we need to shade. Or we're going to shade less than or greater than. We're going to shade above or below. Well, the inequality in the problem is a greater than symbol, so we're going to shade above the line. So all this stuff over here. So what does this mean for us? Well, this means if this guy sells 90 bushels of cherries and 0 bushels of peaches, he would make 350 bucks. Actually, he'd make a little bit more than that. If he sold anything in the blue, so if you find a crisscross here, so if I picked this point right here, this is 60 bushels of cherries and 60 bushels of peaches. If he sold 60 of this and 60 of that, he's going to have lots of money, a lot more than 350 bucks. Okay? So he basically just needs to sell anything above this line to make his profit. Okay? I think we got one last problem. It's yours to try. Here it says Deadpool from Marvel Comics can eat 40 chimichangas per hour. He could also eat 60 tacos per hour. In a food eating contest, he wants to eat at least 80 Mexican meals. Write and graph an inequality show how many hours of eating each type of Mexican meal Deadpool would need to meet his goal. Then I have a little graphic down there for those who don't know who Deadpool is. He likes Mexican food. So, if you could, write and graph an inequality that represents that situation. When you're ready to hit continue, hit play, and we'll go through it together. Okay, so this dude can eat 40 chimichangas per hour. So 40 times chimichangas, because that happens each hour, plus 60 tacos. 60, I don't know if I want to use T for tacos. I guess I will. Use it for now. And he wants this to be greater than at least 80. Greater than or equal to 80. So we need to figure out how long he has to eat from each of these to get to his goal of 80 meals. So this is without the x and the y, so let's plug an x and a y in there. So 40x plus 60y is greater than or equal to 80. And then we would solve for y. So I'm going to subtract 40x. 60y is greater than or equal to negative 40x plus 80. Divide by 60. Y equals this is a negative 2/3 x. This is a 4/3. And these decimals are going to be a little bit easier to graph, well, as decimals. Instead of fractions, let's have some decimals. So on a handy-dandy calculator, if you got it, I don't need it, y equals a negative 0.6 repeating x, plus 4/3 is 1.3 repeating. So we said x is chimichangas. Let's call it chims. And this is tacos. T-A-C-O-S. All right. Now, look at this scale. We need 1.3 as our x-intercept. Or, I'm sorry, as our y-intercept. And then the scale's going to go down by, like, almost a half. So how about we do 0.2. This one was a little bit harder to graph because there's decimals. 4, 6, 8, no, not 10, 1.0, 1.2, 1.4, 1.6, 1.8, 1.2.0. I can count. 0.2, 4, 0.6, 8, 1.0, 1.2, 1.4, 1.6, 1.8. There we go. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Yep, all right. So the y-intercept is 1.33333, which is right around there. Close enough for government work. Now, we need to find our scale of 0.6. So what we're going to do is we're going to go down 0.6, so 0.2, 0.4, 0.6, and over 1. You ready for this little trick? We're actually going to go over to 1. Because we were at 0, we're now at 1. So we went 1 unit this way, 0.6 units that way. Down 0.6, over 1. Honestly, I don't want to make another point. That's as far as I want to go. So, I mean, all you really need to make a graph is 2 points. That's enough for me. I'm going to go from there to there. And that would be my yeah, that'd be my answer. So let's see here. Shading. I put an equal sign. This should not be an equal sign. It should be a greater than or equal to. So it means I want to shade greater than this line. So anything up here in the blue is in the good range. That means he's going to eat more than 80 Mexican meals within 1 hour. So he spends, or not within 1 hour, it's how many hours he would need to eat each of them to have 80 Mexican meals. So if he spent 2 hours eating tacos, he's going to have more than 80 meals. He's actually going to have 120. If he spent 1 hour eating chimichangas and 1.4 hours eating tacos, I can't see the blue on blue, nice, right in there someplace, he would have more than his 80 meals. Okay? So, moral of the story. Write the inequality as a verbal model. Translate to an actual inequality with x's and y's. Solve for y to make it into slope-intercept form to make it easy to graph. Plot the y-intercept. Move the way the scale tells you to move. Here we went down 0.6 over 1. Draw your line. Make sure you know if it's a solid line or a dotted line. And then finally shade above the line if it's a greater than, or below the line if it's a less than. And that's it. That's a lot of work, a lot of little steps, lots of places to make little mistakes. So, let's see if you're paying attention. How do you graph linear inequalities into variables? See if you can put an answer on your own. Don't go back to the video and listen to it again, unless you really need to. But how do we graph these things into variables? Go ahead and do it now. Okay, here's what I said. I have mine broken down into about 4 steps here. So I said, first, solve for y to get slope-intercept form. Then, you plot the y-intercept on the y-axis. Then move the way the slope tells you to move to get the next points. All good so far. Then you draw a solid line if the inequality is an or equal to, if it has an extra line underneath, or just a hollow or dotted line if it's greater than or less than. Finally, after you have your line drawn, you shade above the line if it's greater than. You shade below the line if it's less than. And that's what we did. And there's the homework. Page 409, numbers 3 through 14, and 17 and 18. This has been lesson 6.7. Thank you for watching.